Okay, this is your geometry review. That's part 2. So part 2 of geometry, and today we're going to focus on how to classify triangles, classify quadrilaterals. We're going to talk about triangles and what their angles measure up to, perimeter of some different shapes, and that'll be it. So let's start with classifying triangles. And triangles can be classified by their angles, and they can also be classified or named by their sides. So first let's start by talking about the different names for triangles when you look just at their sides. There's 3 kinds. There's an equilateral, there's isosceles, and scalene. Now, I know you've heard of these before, but let's review what they are and draw some pictures. So an equilateral triangle, lateral means sides, and that prefix there at the beginning should make you think equal. So this has all sides are equal. Isosceles has 2 sides are equal. And so then the only possibility left is scalene, which is no equal sides. So and let's draw a little picture here. So an equilateral triangle, you have a triangle that looks something like that, and you can put a little mark on there to show that all the sides are the same with that little mark. Isosceles could look like this, and only 2 of the sides are the same, so I just put 2 marks. And then a scalene can look all different ways, but maybe something like this. None of the sides are the same. Okay, so then we can also do it by the angles. So every triangle actually has 2 names. It has a name by its sides and a name by its angles. And you guys know this. We've actually talked about this some. There's an acute triangle. We have an obtuse triangle. And then we also have right triangles. So an acute triangle, because all of these actually have acute angles in them, but an acute triangle has all acute angles. There's a symbol for angle right there. It looks kind of like a less than, but it's an angle sign. And remember, acute is that word, that type of angle means less than 90 degrees. That's what an acute angle is. So all the angles are less than 90. An obtuse triangle has 1 obtuse angle. And remember, an obtuse angle is more than 90 degrees. That's an obtuse angle. And then a right triangle has 1 right angle. And we know right angles are 90 degrees. All right, so those are different ways we classify them. Now let's talk about classifying quadrilaterals. Oops, left the A out. Let's try that again. Quadrilaterals. Now, again, hopefully you see that word lateral inside the name of quadrilateral. Lateral, we already said, means sides. And then quad, what's quad mean? 4. So 4 sides. So a quadrilateral, got all kinds of quadrilaterals, but it's got to have 4 sides. So let's put that down. All quadrilaterals have exactly 4 sides. Just like triangles, all have 3 sides. So let's, some different ones. We know, we talked about this already, a parallelogram. We did this in earlier lessons. And typically, you'd see them like that. A rectangle. Remember, a rectangle is a type of parallelogram, but it's the one that has 4 right angles. And then a square is also a parallelogram. It's also a rectangle, but it's a special rectangle that has those 4 right angles like a rectangle does, but it has your 4 equal sides. And then just to review, with a rectangle, the opposite sides are equal. Opposite sides match, same with a parallelogram. But some parallelograms don't have right angles. If they have right angles, we call it a rectangle. And then we've got a rhombus. And a rhombus is a type of parallelogram. These are all quadrilaterals though. A rhombus is a parallelogram that looks more like that first one, but all the sides are the same length. So it's a little bit like a square that got squished. So there's our rhombus. And let's see, what else? Another 4-sided figure would be a trapezoid. And we learned about those a lot in 6th grade math. A trapezoid, oftentimes they'll look like this. And opposite sides, it has one pair of parallel sides. I'm going to do a little arrow on the parallel side. So those would be parallel. One pair of parallel sides, but not 2. Parallelograms, all those first 4, those all have 2 pairs of parallel sides. But a trapezoid only has 1 pair of parallel sides. Okay. And another way a trapezoid could look, you could have one that looks like this. So sometimes they have right angles on them, but again, notice it only has 1 pair of parallel sides. That one's going up that way. All right, so that's trapezoid. And okay, that's the main thing of that. Let's talk about angle measures of triangles. Now, does anybody know, when you think a triangle, we know has 3 sides, has 3 angles. Did you know, and if I were in class with you, I would do a little demonstration, but I'm not. So I'm just going to tell you that, and maybe I could show it to you here quickly. Let's take a triangle, and maybe we'll say that this, well, let's say it's an equilateral triangle. And so equilateral triangles actually have all angles are 60. Well, if I were to get out a pair of scissors and I were to snip off each of these corners, this is what I would do with you if I were there. So now I've got these 3 pieces. There's one piece, that's 60. And then got another piece here that's 60, and then this one would be 60. So it turns out that if you take all 3, notice what they add up to. They all add up to, all 3, well, they make a straight angle that's 180 degrees. And it turns out that every triangle, all 3 of the angles will always add up to 180 degrees. So be sure and write that down. The 3 angles of a triangle always add up to 180 degrees. So that's really helpful if you know 2 of the angles, but you don't know the 3rd angle. So let's say we have a right triangle. So we know that's 90. Say this is, we'll do a 60 degree here. Well, what would this angle be? Well, we know that one angle is 90, plus that one is 60. So far we have 150 degrees. Well, how much is left for that question mark spot? Well, we know they need to add up to 180, so 180 take out the 2 that we know, we're left with 30. So therefore, this angle has to be 30 degrees. 30 plus 60 plus 90. And so you can do that with all kinds. If one angle's missing, you can, why don't you try one? Let's say that this is 50, this one is 70. Now it's not really drawn to scale. So find out what the question mark one is. Well, we know that all three together, another way to do it would be to set up an equation. 50 plus 70 plus our question mark, we could put x if you want, is equal to 180. So let's add the 2 that we know, and that adds up to 120. Subtract both sides by 120. See, our equations are helping us. So then the question mark is equal to 60. So that missing angle is 60 degrees. All right. I think that's about it. The only other thing I want to make sure you remember that'll help you with the problems you're about to do is that perimeter, and we mentioned this already, is the distance around a figure. So you need to add up all the sides. You're not going to do the multiplying, you're just going to add them all up. So that'll help. But then, oh, and another term that you need to also know is the term regular. And if we talk about a regular polygon, and polygon is just like poly is many, so a triangle is a polygon, a quadrilateral is a polygon, a hexagon, octagon, you hear the gon. So polygons are different shapes that you're used to dealing with, but a regular polygon is a special kind, and it's really the ones you do work with and see a lot, but you just maybe didn't know it was called a regular polygon. And that means that all the sides are equal on a regular polygon, and also all the angles are going to be the same. So like an equilateral triangle would be a regular polygon because all the sides are the same and all the angles equal 60. A square would be a regular polygon because all the angles equal 90 and all the sides are the same. An octagon, a stop sign is a regular octagon. So you get the idea, but the main thing you need to know for the problems you're going to be doing is that all the sides are going to be equal if it says that it's a regular polygon. A regular quadrilateral is a square. All right, I think you have all the information you need to go ahead and get started.